What is an intermediate value theorem? Let's draw a function like this. It should be a and let it be b. The y value corresponds to a is f of a, and the y value corresponds to b is f of b. A function must be continuous in the interval a to b. Okay, and f of a shouldn't be equals to f of b. So these are the conditions that must be satisfied in order to apply intermediate value theorem. So if the function is continuous on an interval a to b and f of a is not equals to f of b, then if we take any random values between f of a and f of b, for example, let's take k, right? If we take a value k, then if that k is between f of a and f of b, then there exists a value c that must lie between a and b in such a way that f of c would be equals to k. First thing, we'll have to figure out what the value of function when x is 1. So negative 1 whole square minus negative 1 plus 1. This is 1 plus 1 plus 1. It is 3. Second thing, f of 5. It would be 5 square minus 5 plus 1. So that's 25 minus 20 plus 1. That is 21. So we can see that f of negative 1 and f of 5, the value is 3 and 21. Then k is 8, so k lies between f of negative 1 and f of 5. So yes, it satisfies the intermediate value theorem because this is a polynomial function, so it must be continuous in any interval. So negative 1 to 5 is continuous. So the value 8 lies between f of negative 1 and f of 5. So there must exist a value c for which this value would be equals to 9. The value of x we got is x equals to 3.19. This will be our answer, 3.19. It lies between negative 1 and 5. Suppose f is a continuous function on interval 0 to 4 and f of 0 is equals to 1 and f of 3 is equals to negative 3. So the question is, which of the following statement is correct? So the intermediate value theorem says there must be at least one value. So we can say there must be at least one value. It could be more than one. So exactly one we cannot say. Has more than 1 0? Yes, it could have more than 1 0. It can have more than 2 zeros. That we cannot say. It could have in less than 2 zeros. And exactly 2 0? No, we cannot say for certainty, with certainty. So then